A warm greeting everyone. I'm Harshita Sisodia from ABS Engineering College. I'm a trainee at PinE Training Academy. Here we are learning various subjects like analog layout and scripting languages such as Bash, Tickle and skill scripting. Now I would like to introduce my teammate Shahil.
Hello everyone, my name is Sahil Khare. I did my engineering from Kite Group of Institution, Ghaziabad in Electronics and Communication. I'm also a trainee at Pine Training Academy. Today we are going to present our skill-based project CALSI-AREA, which helps the user to create the PR boundary according to user-defined inputs. It helps the user to find any object which is outside the PR boundary. It helps to determine the dimensions of PR boundary such as its area, height, width, and it also helps to create PR boundary. Now my teammate Harshita Sisodia will give the presentation of it. Up to you.
Thank you, Sahil. As my friend has already listed what are the various features our tool will be providing. Moving forward, our skill scripting project is called CALSI-AREA. It's a strong area calculating feature which is available in Virtuoso Layout Editor. Our objective will be to calculate the area of various shapes such as polygon, paths and rectangles. And our second objective will be to create a PR boundary according to the user's need and to calculate the dimensions of a PR boundary if it already exists. Moving forward, why do we need this feature? Like when we are implementing area calculation, why do we need it? As we know, calculating the area requires a multiplication of dimensions. If I ask you to multiply these two values, it would be quite easier, right? But what if I say that I want to calculate these values, having lots of decimal places? It would take some time, right? Because we also need accuracy and we also need to know the area. Moving forward, our tool gives the accessibility to get these areas easily. As you can see, it's a window of layout editor, and in the main menu we have attached our CALSI-AREA project where you can access all the item list with the drop down menu with features such as area of selected shape and PR boundary. Our first option is area of selected shape, by which we can access this GUI and we can select the shape of which we want the area of, and this will be the result window where the user can see the information of various shapes like area, layer number and purpose and its name. As you can see, here we have layout of an inverter and a mux. Here we have implemented mux using NAND cells as a standard cell. As we can observe, these layouts are made up of various rectangles, various paths and various instances like multi-purpose path over here and a standard cell over here. So the user can easily select these rectangles, paths or any object to obtain its area. Now why do we require to calculate the area of a, let's say, rectangle? As being a newbie, most of the engineers must have encountered this error that metal 1 area is less than required. Using our feature, the user can simply select that specific metal 1 area and obtain its area in order to avoid that DRC error. And for the area of path, it can be accommodated in calculating the antenna ratio. But as we look closely, we can see there are various instances as well. What if I want to calculate the area of an instance? Let's take the example of mux. Here I have implemented mux using NAND cells. If I want to calculate the area of this NAND cell, I can simply overlap it with a rectangle and select this rectangle as an object and obtain its area. Let's say I have this layout. What if I want to calculate the area of these current wires? Traditionally, I would have calculated the area of these small rectangles and sum it all up to obtain its area. But using our tool, I can simply overlap it with a polygon over here. And I can select this polygon and obtain its information. Like as you can see in a result window, we can also obtain the area of polygon and its layer number, purpose and name. We have also provided an option to save all the information of the result window for the user's ease. Moving forward with our second objective, which is to create a PR boundary and know the elements which are outside it. The PR boundary option can be found in our second menu of our item list, and there will be option to create or a calculate. The calculate PR boundary option can be used if you have a PR boundary on your layout and you want to know its information. As you can see, it has a PR boundary, and I can know the information of this PR boundary, its height, width, and the area. And I can also know the elements outside it by simply clicking the show button. It can highlight me or select the elements which are outside it. Our second option is to create a PR boundary. We have provided the user choices by which the person can easily create a PR boundary. Why do we need this feature? We would require this feature, let's say I want to create a standard cell. As we know, standard cell has a definite height, but its width can vary. So I can use this function of height plus width or height or area, in which I can fix the height of my standard cell and can easily modify the width according to my need and according to area and aspect ratio. If I'm asked to create a layout of a specific dimension or orientation, I can simply create this PR boundary and ensure that my layout is enclosed in within that PR boundary. So these were the few application of our functions. And we have also provided a help menu over here by which the user can simply access the help manual which we have created for our tool. For the future scope, in area calculation feature, we have decided to add the area calculation of standard cells and P cells, and for height as PR boundary, we have thought of adding the feature of track heights, where we know usually the standard cell of digital layouts, it is generally calculated in the height of tracks. It can be wire to wire, line to line, or any other. So in future, we can add this feature to implement the PR boundary according to the track heights. Thank you everyone for your attention. Now I would like to ask Shahil to proceed with the demo of our project.
Thank you, Harshita, for giving the presentation of our project. Now I'll give you all the demonstration of our project CALSI-AREA. So as you can see, this is a layout window. We have created a CALSI-AREA button in a menu bar. When we click on it, we have the three menu items: area of the selected shape, PR boundary, and help. When we go further on the PR boundary, we have further two menu items: create and calculate. Let's check the area of a selected shape. When we click on it, now suppose we want to find the area of any shape, suppose of this path of metal and this path of poly. I click on a select shape from layout, then I select these two paths whose area I want to calculate. Then I'll go back to my form, click on count selected shape. You can see the shape count comes 2 as I selected the two shapes. I'll click on OK. Now a result window will appear which shows all the details of the selected shape, such as path. Its area is 0.122 micron square. Layer name is poly. Layer number is 10. Purpose is drawing. Similar for the path of metal 1. Here we have given a button save. When we click on it, this all data will save into a file whose details can be shown in a CIW window. You can see a file named CALSI-AREA. A file named CALSI-AREA underscore result.txt has been saved to this directory. If we go here, you can see a file is created which contains all the detail of that selected shape. Going back, we close it, going back to our layout. Now suppose we have the layout of this inverter, and I want to find the area of how much inverter area is covering. I'll go on area of a selected shape, click on select shape from layout, then I'll draw any layer which overlap this inverter. Suppose I here select the via1 and overlap with via. Now I'll select this via, click on count selected shape, press on OK. Here you can see the area comes 19.52 micron square. Here we can evaluate that the area that our inverter is taking is 19.59 micron square. Click on close. Goes to the next. Now comes to the next feature of our project, PR boundary creation. Now we go on the PR boundary, click on create button. Here a form will appear which have the options area plus aspect ratio, height plus width, and area plus height. Now suppose I want to make the PR boundary according to area and aspect ratio. I give the area of 10 micron and with aspect ratio of 3:1. Click on apply. Here you can see a PR boundary is created with the information pop-up PR boundary is created. Now suppose I want to make a PR boundary using other inputs. I click on recreate, click on a height plus width. I'll simply give the height, suppose 2 micron and width of 5 micron. I click on apply. Here you can see a PR boundary is created with information there. Now suppose the PR boundary is already created and we again click on a create button and we give any inputs like 10 or 1 or 5 on click on OK. The information come the PR boundary is already present. Now suppose the PR boundary is like this and we click on a calculate button. Here you can see the dimensions of a PR boundary comes which shows the length of a PR boundary is 5 micron, width is 2 micron and area is 10 micron with the elements outside are 35. Click on a show button, you can see all the elements which are outside the PR boundary and are going from inside to outside are highlighted. Okay. And apart from this, we have created a help button. If the user encounter any type of difficulty while executing our project, he can use the help button. When we click on it, a help manual will appear which contains all the steps that he has to take to operate our CALSI-AREA. It have all the warnings that might appear while executing CALSI-AREA, and it also have the troubleshooting section which helps him to solve the problem. Thank you everyone. That was the conclusion of our demo.
Thank you everyone for watching our presentation. First of all, we would like to thank Pine Training Academy for providing us with this platform and Vaibhav sir and all our mentors for their constant guidance and support. And I wish all the best to all the aspiring engineers for their future endeavor. If anyone has any query or doubts, feel free to reach us and use the comment section. Thank you.
Yeah.